Experiment 3. Aim. 2. Draw the I to V characteristic curve of a P2N junction diode in forward bias and reverse bias. Apparatus and materials required. A P2N junction, semiconductor, diode. A 3-volt battery. A 50-volt battery. A high-resistance rheostat. 10 to 3-volt voltmeter. 10 to 50-volt voltmeter. 10 to 100 meters A ammeter. 10 to 100 mu A ammeter. One-way key. Connecting wires. And pieces of sandpaper. Theory. Forward bias characteristics. When the P section of the diode is connected to positive terminal of a battery and N section is connected to negative terminal of the battery, then a junction is called forward biased. With increase in bias voltage, the forward current increases slowly in the beginning and then rapidly. At about 0.7 volt for SI diode, 0.2 volt for GE, the current increases suddenly. The value of forward bias voltage, at which the forward current increases rapidly, is called cut-in voltage or threshold voltage. Reverse bias characteristics. A junction is called reverse biased when the P section of the diode is connected to negative terminal of high voltage battery and N section of the diode is connected to positive terminal of the same battery. When reverse bias voltage increases, initially there is a very small reverse current flow, which remains almost constant with bias. But when reverse bias voltage increases to sufficiently high value, the reverse current suddenly increases to a large value. This voltage at which breakdown of junction diode occurs, suddenly large current flow, is called Zener breakdown voltage or inverse voltage. The breakdown voltage may start from 1 volt to several hundred volts, depending upon dopant density and the depletion layer. Diagrams. Procedure. Step for forward bias. 1. Make circuit connections as shown in the circuit diagram. 2. Make all connections neat, clean and tight. 3. Note least count and zero error of voltmeter, V, and millimeter, MA. 4. Bring moving contact of potential divider, rheostat, near negative end and insert the key K, voltmeter V and millimeter MA will give zero reading. 5. Move the contact a little towards positive end to apply a forward bias voltage, V, of 0.1 volt. Current remains 0. 6. Increase the forward bias voltage up to 0.3 volt for GE diode. Current remains 0. It is due to junction potential barrier of 0.3 volt. 7. Increase VF to 0.4 volt. Millimeter records a small current. 8. Increase VF in steps of 0.2 volt and note the corresponding current. Current increases first slowly and then rapidly, till VF becomes 0.7 volt. 9. Make VF is equal to 0.72 volt. The current increases suddenly. This represents forward breakdown stage. 10. If the VF increases beyond forward breakdown stage, the forward current does not change much. Now take out the key at once. 11. Record your observations as given ahead. Steps for reverse bias. 1. Make circuit connections as shown in the circuit diagram. 2. Make all connections neat, clean and tight. 3. Note least count and zero error of voltmeter, 6 and micrometer, mu A. 4. Bring moving contact of potential divider, rheostat, near positive end and insert the key K, voltmeter V and microammeter mu A will give zero reading. 5. Move the contact towards negative end to apply a reverse bias voltage, VR, of 0.5 volt, a feebly reverse current starts flowing. 6. Increase VR in steps of 0.2 volt. Current increases first slowly and then rapidly till VR becomes 20 volt. Note the current. 7. Make VR is equal to 25 volt. The current increases suddenly. This represents reverse breakdown stage. Note the current and take out the key at once. 8. Record your observations as given ahead. Observations. For forward bias junction diode, range of voltmeter is equal to, calculate this in volt. Least count of voltmeter is equal to, calculate this in volt. Zero error of voltmeter is equal to, calculate this in volt. Range of millimeter is equal to, calculate this in millimeter. Least count of millimeter is equal to, calculate this in millimeter. Zero error of millimeter is equal to, calculate this in millimeter. Table for forward bias voltage and forward current. For reverse bias junction diode, range of voltmeter is equal to, calculate this in volt. Least count of voltmeter is equal to, calculate this in volt. Zero error of voltmeter is equal to, calculate this in volt. Range of microammeter is equal to, calculate this in mu A. Least count of microammeter is equal to, calculate this in mu A. Zero error of microammeter is equal to, calculate this in mu A. Table for reverse bias voltage and reverse current. Calculations. For forward bias junction diode, plot a graph between forward bias voltage Vf, column 2, and forward current If, column 3, taking Vf along x-axis and If along y-axis. This graph is called forward bias characteristic curve, a junction diode. Note: take your own readings, the graph is given for your reference. For change from point A to B. Hence, junction resistance for forward bias. For reverse bias junction diode, plot a graph between reverse bias voltage VR, column 2, and reverse current IR, column 3, taking VR along x-axis and IR along y-axis. This graph is called reverse bias characteristic curve of a junction diode. From graph, for change from point A to B. Hence, junction resistance for reverse bias. Note: take your own readings, the graph is given for your reference. Result: junction resistance for forward bias is equal to 40 ohms. Junction resistance for reverse bias is equal to 2 into 10 to the power 6 ohms. Precautions. 1. All connections should be neat, clean and tight. 2. Key should be used in circuit and opened when the circuit is not being used. 3. Forward bias voltage beyond breakdown should not be applied. 4. Reverse bias voltage beyond breakdown should not be applied. Sources of error. The junction diode supplied may be faulty.